All right, great. So using the tasks, the durations, and the different task dependencies that exist, it turns out that we can create different types of visual representations for the project schedule. And specifically, we are going to just quickly walk through some key charts. We will look at how to derive a work breakdown structure using such information. And then we'll quickly go through a process of creating a Gantt chart, a timeline. And then we'll look at how we get to identify a critical path and computing things like the project duration and the slack associated with the different activities using an activity network diagram. And then finally, we'll just quickly walk through the creation of a so-called RACI matrix, right? Great. And all these different presentation for the schedule are going to have to appear in your project proposal. So you want to pay careful attention to this process. So for the most part, you typically use the task, the durations, and dependencies as input. You start with the work breakdown structure, which is typically your initial starting point once the project has been commissioned, right? Once you're given a go-ahead, well, you win that bidding process. All right, so question is, how exactly do you come up with work breakdown structure? Well, you need to realize that a work breakdown structure is nothing more than a way of organizing project activities into manageable tasks, right? We have highlighted or mentioned numerous times that your typical project is composed of activities, and the activities are broken down into tasks. What a work breakdown structure does is it helps you break apart activities and then further break up the activity. So it helps break down the project into activities and the activities into tasks, right? And you routinely come across text or literature that will emphasize the fact that work breakdown structure is deliverable oriented, because one of the key focus areas of the work breakdown structure, these entities called work packages. So actual byproducts of the different tasks associated with the project. And so the focus quite naturally is on the project activities, the deliverables, and the times associated with activities and deliverables. So usually these tasks associated with the project are represented in a hierarchical structure, with the major tasks being high up the hierarchy, and then the subtasks appearing right below that, right below the different major tasks or the summary tasks. And it turns out that you can actually represent work breakdown structure using a graphic. You can use text if you want to, or a table, similar to what is here on the slide. The most common representation is a hierarchical graphical representation. But either way, irrespective of which method you're using, the idea is to highlight the key deliverables and times associated with the project. So some key elements associated with the work breakdown structure, as you're constructing it, you realize that there are entities called summary tasks. So it's usually the case that the top level task, the top level structure of work breakdown structure is actually the project name. The level 2 entities are what we're referring to as summary tasks. So if we were to think of it from the perspective of the different projects we're working towards, your level 2 tasks would be the different phases associated with the project. So things like requirements engineering, system design, implementation, right? The subtasks are all the different tasks that will fall below the summary tasks. So this would be level 3 tasks, level 4 tasks, level 5 tasks if you want to. And then the work packages. A work package is an actual byproduct, a deliverable. And it's usually the lowest subtasks, this lowest subtask or the leaf of the structure if you're using a graphic to represent the WBS. Recurring tasks would be activities that occur on different times of the project timeline, right? So things like meetings, for instance. If you decide as a group to say you're going to have meetings every week, then you'd have recurring tasks in the form as group project meetings. A milestone, somewhat related to a deliverable, with the difference that this just marks an end of an important activity associated with the project. So it's specified at a single point in time, right? A date. Compare and contrast with an activity that will span multiple days. A milestone will typically occur at a single point in time, maybe just one day. Right? So creation of a WBS is quite simple. You first of all start at the top level with the project name, and then you start identifying the key high-level summary tasks associated with the project, and then you derive the subtasks associated with the different summary tasks. An example I lifted from Wikicommons here of an aircraft system, and it is that our aircraft system is the project name, which is level 1, and then level 2. Level 2 would be the summary tasks associated with this aircraft system: industrial facilities, data, training, right? And then associated with these summary tasks are subtasks, which could either be milestones or deliverables. The numbering, as mentioned here, begins with level 2 tasks, so the numbering begins here, right? So if this was 1, this would be 2, 3. Everything that falls below here follows similar numbering system. We're taking into account the hierarchy. So this is 1, 2. This would be 1.1, 1.2, 1.3. Yeah, 1, 2, 3, 3.1, 3.2, 3.3, 3.4. I thought to help emphasize this issue of numbering, I would use an example that is somewhat closer to home. So if we were to come up with a work breakdown structure associated with the different assessment activities associated with ICT 3020, this is a sort of WBS we would come up with, right? Top level structure is the name of assessment, which is ICT 3020 assessments. Level 2 structures would be a summary tasks. In this case, the summary tasks would be the different categories of the assessment, right? The numbering starts with the different categories of the assessment. So class theory test would be 1, class theory test number 1 would be 1.1, class theory test number 2 would be 1.2, right? If you have 1, 2, 3, 4 layers, numbering for the 4th layer will be composed with 3 hierarchies, right? 1, or rather 2, 2.1, 2.1.1, 2.1.2. So essentially what we are saying is, if you look at this this particular subtask, but we're just looking at the numbering, we know that it is associated with immediate subtask 2.1, and then parent task or summary task 2. Yeah, so you can easily trace it high up the tree here by just looking at the numbering here. Okay, next up is so-called Gantt chart. But again, just quickly go back here. Your starting point during project planning, insofar as activities and tasks are concerned, is a work breakdown structure. You want to come up with a hierarchy of the different activities and tasks associated with the project. Maybe now would be a perfect time to showcase to you a realistic example. There's a project that I was involved with. I supervised some students way back, right? Can't remember the year. It must have been 2018, 2017. I can't remember. But I'll go right to the appendices section to highlight or to showcase what sort of work breakdown structure they came up with. Remember, we said the work breakdown structure could either be represented using graphical notation or table, right? So what these guys chose to do, right? These guys here, this example, is they chose to represent their WBS using a table, right? So you can easily see here that and they neglected to number the different tasks here, but you can see that the summary tasks are these things that are in bold here, and then subtasks associated with the different summary tasks here are indented, right? Hope that makes sense. Right. So next up is the so-called Gantt chart. And usually your Gantt chart is used to visualize the entire project duration on the schedule associated with the project. So if you're working on a 1 year long project, as is the case for the 30/20 projects, which is almost 2 semesters, slightly less than a year, what you would do is you'd use a Gantt chart to try and visualize the different activities on the timeline, on the 1 year timeline. So in this case, in this example, you'd have different months here, months broken down into weeks, right? So a year is broken down into months, months into weeks, and then you visualize the different tasks associated with the timeline. So you can see here that the planning phase, for this particular example, the planning phase will begin in week number 1 of April, all the way up to the end of the 2nd week of May, right? With something like this, you gain a sense of when the different activities, when the different activities associated with your project are going to be undertaken and how long they are going to take. I know that the planning phase is going to begin in the 1st week of April and end in the 2nd week of April. The duration is 6 weeks, 1, 2, 3, 4, 5, 6, right? It's very easy to actually visualize the entire duration of the project using a Gantt chart. Compare and contrast with something like this. You wouldn't immediately gain a sense of exactly how long these different activities would be undertaken, right? How long is class theory test number 1, for instance, going to take? You don't know, right? It's hard to visualize the duration associated with class theory test number 1. All right, but sometimes this Gantt chart is used to track the progress of the project, right? So it's usually the case that you'd have a progress bar inside of the this horizontal bar representing the different activities. Let me just quickly go to, and this is a bad example. I wish maybe I haven't configured a Project Libre to show the duration of the project. I would like to think there's a way of doing this. I don't want to waste time trying to fidget around with this, but what would happen is we could potentially visualize the different, progress associated with the tasks. Bearing in mind that if you look at this Gantt chart here, we began in February, right? We are ending in October. So if we're ending in October and we are in April, there are certain tasks that we should mark as complete because they're supposed to have been completed in March, for instance, if you look at this phase here. Right? All right. So in terms of the different elements that make up a Gantt chart, again, so this image here is taken from the recommended text by Ian Somerville, Software Engineering. So if you look up chapter 23, really, this thing is derived from these tasks and corresponding durations and dependencies. Yeah. Everything marked as M in the diagram is a milestone. So project tasks and the associated start and finish dates are represented in the form of a bar. So by looking at task number 1, we know that the start date for task number 1 is week 0. Right? And then we know that the end date for task number 1 is week 2. If we know the start date and the end date, we can derive the duration. It's 2 minus 0, which is 2 weeks, right? So task 1 takes 2 weeks. Milestones and deliverables are represented by a diamond sign, right? So everything that you see in black here, this diamond is a milestone. You can notice that there's M1 here, start, and M4. Essentially, for this particular representation, the reason why you have M3/T2 and T4 is because this particular milestone is dependent on task number 3 and task number 2. Yeah, it has a dependency. All right, so there's also a way of representing these so-called dependencies, and this image I lifted from the textbook doesn't do justice by way of showing the dependencies between the tasks, but you typically represent dependencies using an arrow, right? Arrow from one task going to the task or tasks that depend on that particular task. And then in certain instances, you typically use a Gantt chart to visualize and indicate the critical path associated with a project. We're just going to quickly walk through this example here, a more realistic example that makes use of Project Libre, right? So these screenshots are we actually gotten from Project Libre, and you notice here a couple of interesting things. All these tasks represented in black are more or less like summary tasks, right? The black diamonds would be the milestones and deliverables. The arrows would signal that there's a dependency between the two tasks or amongst the tasks. All right, so first off, how do you represent the tasks? Key things that should be associated with your task when coming up with the Gantt chart is you must identify the ID, the unique ID associated with the task name, start date, and finish date. Typically, the case 2 you are using would derive the duration. And then more importantly, you also explicitly define the dependency that exists. In Project Libre, the dependency is represented by predecessors, right? So anything that has a predecessor value here signals that the task with this ID is linked to this particular task. So class theory test number 2 has a dependency on task ID 2. Task ID 2 is class theory test 1. All right. Like I said, summary tasks will typically envelope all the tasks, all the subtasks that fall under them, right? So in this particular example, what we're saying is if we were to go back to the work breakdown structure, this would envelope these two subtasks. Right? Milestones are represented by these black diamonds, right? Or diamond icons. And it's usually customary to associate or indicate the date linked to the milestone or deliverable. Just because if you look at this visual representation, without the date, it's very hard to figure out when this particular milestone or what particular date is associated with this particular milestone, which is why you need to have a date alongside the milestone or the deliverable, right? For Project Libre, it's quite easy to do. You just have to set, I guess, a configuration, a parameter that will indicate the date associated with the milestone. So we know that this particular milestone would be achieved on the 25th of September. Yeah. Great. The critical path, like I said, depending on the tool that you use, most tools will do this, but it's represented using a different color scheme. For Project Libre, the critical path will be represented, or tasks that fall within the critical path will be color coded using, is it purple or red? Probably purple, I guess, right? So again, if you actually open up Project Libre here, critical path associated with this project, there are two of them. There's this path here and this one. Again, if any of the tasks on these, any things that fall within this critical path are delayed, then the entire project will be delayed. That's our idea behind the critical path. All right, so the other useful graphic that is used to represent the project schedule is the so-called activity network diagram. Typically used to determine the critical path associated with the project, also use it to compute the total duration of the project. And more importantly, the different slack values associated with the various activities or tasks aligned with the project. Sometimes your slack would be referred to as float or total float. So everything you see as TF here would be the slack value, the total float. Like I said, typically use this to identify the critical path. Key elements here is earliest date, early start date, early finish date, late start date, late finish date, the duration associated with the task, the slack, and the activity name. These entities such as early start date, late start date, early finish, and last finish, including slack, also would be derived. So the only input that goes to the different activities is the duration and the activity name. And I should mention here that as you are reading up online, probably different conventions would be used to represent the various activities, but the convention or the notation I'm using in these slides is like so. So each activity will be represented as a block. A block will have the early start date on the top left corner, followed by the duration, right? And then finally, still on the top, the early finish date. The middle number would be the activity name. The numbers that appear on the bottom row would be the late start date, the slack, and the last finish date in sequence. So again, the input for the activity network is typically, it's essentially your task IDs or the task names, the associated durations, and the dependencies that exist amongst the tasks. So again, you remember that I mentioned that one of the very first things you're going to have to do is come up with the WBS or work breakdown structure. What you provide as input to, as you're coming up with the work breakdown structure, what you do is you come up with tasks, how long it's going to take for you to work on those tasks, and potential dependencies associated with the different tasks. That's all you need. So using these three different values or aspects, we can actually derive an activity network. So simple process we're going to use here as we are walking through an example of creating a network activity diagram associated with these particular tasks is we'll first of all create a dependency tree for all the tasks. And then we will go through a forward pass so that we can compute the duration of the project. And then we go through what's called a backward pass so that we can compute the slack, right, associated with the different activities. And then once we are done with that, of course, at the end, we compute the duration, and then we also identify the critical path and the slack values associated with the different activities. Yeah, so forward pass, backward pass, and in the process, what we will be doing is we'll be also computing these values here: early start date, early finish date. So during the forward pass, using the activity name and the duration as input, we compute the early start date, early finish date. Using the backward pass, we compute the late start date and last finish date and the slack. Easy process. We'll look at this just now. Okay, so we're going to start off by just creating our dependency tree. And we'll, bear with me, we're going to take a few baby steps so that people understand exactly how to do this. So we do this task by task for us to build this dependency tree. We start with task number 1. We notice that task number 1 has a duration of, a dependency tree only needs the only input we need here is the task ID and its dependency. So task number 1 has not any dependency, right? So 0 dependency. So what we do is we write a block, T1 there, right? Remember I said early start, early finish, late start, late finish, slack, task name. We go to the next task, task 2. Task 2 has no dependency, so we just put the block for task 2. We go to task 3. Task 3 has a dependence on task number 1, so we draw an arrow originating from 1 going to 3, right? 3 is dependent on 1. Task 4 has no dependencies, so we just write the block. Task 5 is dependent on T2 and T4. So we draw an arrow from 2 and 4 going into 5. 2, 4, arrow pointing to 5. Task 6 has dependencies on task 1 and task 2. 6, task 1 and task 2. Task 7 is dependent on T1, yeah, arrow pointing to T7. T8 has a dependence on T4, arrow from T4 to T8. T9 has a dependence on T3 and T6, so arrows from T3 and T6 going to T9, yeah, T3, T6 going to T9. T10 has a dependence on T7 and T8, so from T7 and T8 arrows pointing to T10, yeah, T7, T8. T11 has a dependence on T9, right? T11 has a dependence on T9, so arrow from T9 to T11. And then finally, T12 is dependent on T10 and T11, so arrows from T10 and T11 going to T12. So we would have created our dependency tree. And then what we do is we indicate the durations associated with all these different activities. I mean, what we could have done is, as we were writing the different blocks here, we could have been taking note of the durations for the different blocks. But what I'm doing in this walkthrough is, after I'm done with the dependency tree, I just indicate the different durations associated with all the different activities, right? So once you indicate the durations, you then go through the forward pass. So the way that you go through the forward pass is you start with the initial tasks, right? Tasks that don't depend on anything at all. It doesn't matter really. You can start with the very first task. In this case, I'm going to go through the tasks in sequence. So T1, T2, T3, T4, all the way up to T12. Because T1 is the starting task, the early start date is 0. The early, remember, notation that I have here. Early start date, early finish, duration, activity. Yeah. So for the beginning activities, T1 is the beginning activity, early start date is 0. You compute the early finish date by adding early start plus duration. So 0 plus 10 gives you 10. For T2, again, start is 0. So we add 0 to 15 to get 15 for early finish. For T3, the early start is going to be the early finish for the preceding task. Yeah? So you see arrow pointing from T1 to T3. T3 has a dependence on T1, so early start here is 10. 10 plus 15 gives us 25. T4, if you notice T4, is the very first task. Start is 0 as well because there's no arrow pointing to it. So 0 plus 10 gives us 10 as the early finish. T5, on the other hand, has a somewhat unique trait here. It has 2 arrows pointing to it. Now, when you have 2 arrows pointing to an activity, 2 or more arrows pointing to an activity, and you want to compute the early start date, what you do is you get the maximum value of the early finish dates associated with the tasks on which that particular task is dependent on. So in this case, T5 has a dependence on T2 and T4. So we shall get the maximum between T2 and T4, which is 15, right? It's either 15 or 10. So 15 is maximum. We put 15 here. We add 15 and 10, we get 25. We go to T6. T6 has a dependence on T1 and T2. We'll get maximum between 10 and 15, which is why we'll have in here 15. We go to T7, 1 arrow pointing to T7, we just pull the 10. We go to T8. T8 has a dependence on T4, we just pull 10. We go to T9. T9 has a dependence on T3 and T6, so we pull the maximum, which is 25. We go to T10. T10 has a dependence on T7 and T8, so we get the maximum, which is 35. We go to T11. T11 has a dependence on T9, yeah, so we just pull 40. finally, T12 has a dependence on T10 and T11. We get the maximum. The maximum happens to be the same, so we just put 50 here. And then finally, we add 50 and 10 and get 60. 60 is, I guess, what we might call a magic number here. This is our duration. Our planned project duration would be 60 in this case. Not very hard here. Okay, so in terms of the backward pass, we pretty much do the opposite, right? For us to compute the backward pass, we start with the last task, yeah, and what we do is we work with the last, so early start, early finish, late start, late finish. Our late finish is going to be, for the last task, is going to be the early finish, right, which is 60. Bring down the 60. And then instead of adding, we are subtracting to get the late start. So 60 minus 10 will give us 50. Then we start working backwards. We go to 11, right? And 11 will just pull the late start, which is going to be our late finish for the preceding task. And then we subtract 10 and get 40. We go to 10, we do the same thing. We get 50, put it there, right? Subtract 15 to get 35. We get to T9, we pull the 40 here, and then we subtract 15. We come to T8, we just pull the 35, right? And subtract 25 from 35. We come to T7, we do the same thing. We push the 35 here, subtract 20 to get 15. And then we come to T6, put the 25, subtract 5 to get 20. Then we come to T5. Now T5 is a pretty interesting case here. Why? Because T5 has T5 is a similar case as this particular task here. Because there's no arrow where it points to, or there's no task that is dependent on it, we just bring down the 25, similar to what we did here. Subtract 10, and then we get 15 here. T4. Now, if you look at T4, right? T4 has two tasks that it depends that are dependent on it. Now, what we do during the backward pass is we get the minimum of the values corresponding to the late start dates. So what is the minimum between 10 and 15? It's 10. So we bring the 10 here. Yeah. T3, right? One arrow here, we just bring 25 from here to here. T2 has two tasks that depend on it. So what do? We get the minimum between 20 and 15, which is 15, right? And then we subtract 15 from 15 to get 0. And then finally for T1, perfect case, and I didn't know that this example would actually result into this, but you realize that there are 3 tasks that are dependent on T1, T3, T7, and T6. Same process, get the minimum between 20, 15, and 10, which is obviously 10. And then you subtract 10 from 10 to get 0. And you'd have finished with your backward pass, right? So if you notice, the only thing we are missing from our activities is the slack, right? Which we're going to compute shortly. But before we compute the slack, it turns out that using the information we have right now, we can identify the critical paths, or critical paths. We can have more than one critical path. We saw this from this particular example, 2 critical paths. So how do you identify the critical path? Well, we just identify the activities which have same values for the early start, late start, and early finish, late finish. So if these numbers are the same, the activities whose numbers, this is equal to this is equal to this, will form the critical path. Observe. If you follow through with this path, all the activities along this path have similar values top to bottom, right? Same goes for this path here, this path, and this path here, right? So we have how many critical paths? 1, 2, 3, 4 critical paths. If any of the activities that lie on these paths are delayed, then the project will be delayed as a whole. Remember, we computed the project duration as being 60 days. If we delay any of these activities on these critical paths, the project duration will be greater than 60 days. Right? Hopefully that makes sense. So how do we compute the slack, or the total float, if you will? Well, turns out that all you have to do is just subtract either the, remember this is early start, early finish, late start, late finish. Either you subtract early start from late start, or early finish from late finish. The value that you get by subtracting these numbers, this and this, or this and this, will be the slack, or the total float. So it's as simple as doing that, right? And you notice that all the activities that fall within the critical paths will have a slack equal to 0, right? So we are just, I am so sorry here. There's a bit of a mistake here. If you notice, I do apologize. There are some values that are not supposed to be 0. For instance, and I do apologize for that. I'll have to change this at some stage. I will, actually. That's besides the point. I will change this. If you look at some of these activities, like activity T7, for instance, 15 minus 10 is not 0, it's 5, right? So these will need to be changed. 25 minus 20 is 5, not 0, right? Okay. So, but the key thing here is that the other way of identifying the critical path is you check for activities which have a slack equal to 0 will form the critical path. Okay. The last chart that I guess the presentation that I want us to discuss really is the so-called RESI matrix. Very simple, and I decided that it would be a good idea for us to discuss this because your proposal is going to be expected to have a RESI matrix in it. And the idea behind the RESI matrix is that you want to assign certain roles, if you will, to individual project team members. So RES is an acronym for responsible, accountable, consulted, or informed. So the idea is you identify the different activities associated with your project, and then amongst your different group team members, you will indicate for each activity who is responsible, who is going to be accountable, who is going to be informed, who can be consulted, right? So if you look at risk management activity, we see that the people that are informed are Michael and Rito, right? For planning and scheduling, the person responsible is Jeff. The person who is accountable for that activity is Michael, right? Following up to make sure that things are being done. But the person doing the actual work, responsibility falls on Jeff. Who is informed? Rito. Who is consulted? You here. That would be like if you was the person's name, right? So the expectation is for the RESI matrix associated with your respective group projects, if your project team is composed of 5 individuals, you must indicate for each activity which of the 5 are going to be responsible, who is going to be accountable, who is going to be informed and consulted. Great. I hope that was useful. So in the next subunit, we're going to look at software pricing and then later on finalize this particular unit by looking at estimation techniques out there. All right, thanks.